Alright, so we're going to have a look at another question. This one comes from the 2022 HSC Advanced Maths paper. This is question 27, so this is quite far through the paper. We are told that f of x is equal to x times e to the minus 2x. We are told that f prime of x is equal to e to the minus 2x minus 2x e to the minus 2x. We are told to show that f double prime of x is equal to the expression given. So pretty much what we're going to be doing is we're going to be differentiating this first derivative and then simplifying, and if we do it correctly, we should get the answer as listed. So we'll do this in two separate, well, we've got to be careful here. We could factorize this straight away. We could make this e to the minus 2x multiplied by 1 minus 2x. Now we can do this as a product rule. This is u, this is v. U is e to the minus 2x. U prime is therefore minus 2e to the minus 2x. We have v is 1 minus 2x. We have v prime is minus 2. So this means our derivative, f double prime of x, is equal to u prime times v plus u times v prime. That's minus 2 e to the minus 2x times 1 minus 2x plus e to the minus 2x times minus 2. So now we're just going to expand all of this and then simplify it. So we get minus 2e to the minus 2x plus 4x e to the minus 2x plus or minus 2e to the minus 2x. So we have minus 2e to the minus 2x, minus 2e to the minus 2x, that's minus 4e to the minus 2x plus 4x e to the minus 2x. I can factor e to the minus 2x out of this. So I get e to the minus 2x times minus 4 plus 4x. I can also factor a 4, swap the order. This gives me 4 times x minus 1 times e to the minus 2x. And this is the answer that we were told to find. So this is the second derivative of the function as provided, double dash f of x. Now we're told to find any stationary points of f of x and determine their nature. Okay, so stationary points, if you recall, f prime of x will be equal to 0. So we have e to the minus 2x times 1 minus 2x is going to be equal to 0. Now this either implies e to the minus 2x is 0 or 1 minus 2x is 0. E to the minus 2x is never 0 because it's an exponential. So we find that 1 minus 2x must be equal to 0. Add 2x to both sides. Divide both sides by 2. And we get x equals 1/2. So there is a stationary point here. The stationary point has x coordinate of 1/2. And so the y coordinate will be the function evaluated when x is 1/2. So y equals f of 1/2, which is 1/2 times e to the minus x. To the minus 2 times 1/2, just to the minus 1. And so this is 1 on 2e. So this is y. So this is the x and y coordinate of the stationary point. This is the stationary point in question. Determine its nature. Well, we're going to use the second derivative for this. We'll plug, so use second derivative. We've got the second derivative, f double prime of x is equal to 4 times x minus 1 times e to the minus 2x. If this comes out positive, it's a minimum. If it comes out negative, it's a maximum. So we have f double prime evaluated at 1/2 is 4 times 1/2 minus 1, which is minus 1/2, times e to the minus 1. Well, 4 divided by 2 is 2, so this is minus 2 on e. This is less than 0. Therefore, x equals 1/2 is a maximum. And this is what we needed to show. It was very sensible to do this using the second derivative because you were asked to find it in the first part of the question. So let's talk through the marking here. This question is worth a total of 4 marks. So you get 1 mark for attempting to use the product rule in part A. You get the second mark for providing the correct solution. So correctly resolving the product rule or some equivalent rule and then showing that the second derivative was what is listed. For part B, you get 1 mark for finding the x value of the stationary point. So finding that x equals 1/2 is a stationary point. And then you get a second mark for providing the correct solution, the xy coordinate, with a justification. It's best in this instance to use the second derivative to do the justification because it was found in an earlier part of the question. Right? If the question baits you into doing something first, and then that can be used in a later part of the question, it's better to do that. The markers will look on that more preferably. So this is how we do question 27, and this is an approximate marking rundown.